Chapter 4.4, Day 2, Example number 4, Factoring Polynomials in Quadratic Form. We are going to use same steps that we have been using, means we are going to find out the common monomial, if there is any. And if you look at letter A, factor 16 x to the 4 minus 81. If you find any common monomial from these two terms, then you are going to factor that out. If we don't have any common monomial, then we are going to skip the first step, and then we are going to find the difference of two square pattern. Since step number 1 is not applicable, so we're going to write NA, difference of two square pattern, that we are going to try and write this as 4x squared to the power 2 minus 9 square. So if you apply the formula a square minus b square equals a minus b, a plus b, that is going to give us 4x squared minus 9 times 4x squared plus 9. If you notice that this factor is again can be written as the difference of 2 square, because it can be written as 2x squared minus 3 squared. And we can apply the a square minus b square equals a minus b, a plus b formula again. So I'm just going to write this formula here, just in case if you want to recall it. That's the formula. Now we are going to write this into a difference of squares. So we're going to write this as 2x squared minus 3 squared, whereas this one remain as it is as 4x squared plus 9. You can further factor this as a squared minus b squared as a minus b, a plus b. So this can be factored as 2x minus 3 times 2x plus 3 times 4x squared plus 9. So this is going to be your complete factors of 16x to the power 4 minus 81. The next we have 3p to the 8 plus 15p to the 5 plus 18p squared. And we can see that here we have common monomial, and that is 3p to the square, because p square is present everywhere and 3 is also factor of every term. So divide this by 3p square, 3p square and 3p square. So factor the common monomial 3p square. Inside you're going to get is p to the 6 plus 5p to the third plus 6. Now think this one as factoring a quadratic equation or expression, which means that we are going to apply the cross method. On the top of the cross we have 6, in the middle you have 5. You can only apply the quadratic if you have first term as 2 and the other one is half of 2. You have 4 or p square. This time you have 6 and half of 6 is p to the third. Now we are going to find out two numbers that we multiply to get 6 and add to get 5. So those numbers are 3 and 2. And now we are going to write down the factors. 3p square as it is. So 3p square as it is, and then the other two factors are going to be p to the third plus 2 and p to the third plus 3. Just remember, if it would be square, then we just write p and p. But right now we have p to the 6, so we're going to use p cubed plus 2, p cubed plus 3. When you multiply them, you can get p to the 6 back. So it means our factorization is correct. So that's your final answer. Number 8, I will call it as a challenge problem. I will not give you this problem for your homework or for your quiz or test, but I'm going to just show you in future if you are going to pre-calculus or calculus classes how to deal with this type of problem. So first you're going to take out the common monomial, that is -1. Try to make the first term positive. So 16 n to the power 4 minus 625 and bracket close. When you take out the negative factor outside, inside the bracket the sign changes. So that's why this plus become negative. Now we are going to make it as difference of square if possible. So that's going to be 4n square of a square minus 25 square. And you're going to apply the a square minus b square formula. So a minus b times a plus b. Now you can break this factor further down, and that's going to be 2n square minus 5 square. That when you break is going to be 2n minus 5 times 2n plus 5, and then the last factor 4n squared plus 25 remain as it is. So this is going to be your complete factorization for the polynomial -16n to the 4 plus 625. Factor 2x to the 13 plus 10x 9 plus 8x to the 5 completely. Common monomial for this one, if you look at the variable, is x to the 5 is common in every term, and 2 is also a factor of every term. So the common monomial is 2x to the power of 5. 2x to the power 5, you're going to divide with each term. Take out 2x to the power 5 or factor it out. Here you left with 13 minus 5 is going to be 8. This is going to be 5x to the power 4 plus 4. Two numbers that you're going to multiply to get 4, and when you add them to get 5 are going to be 4 plus 1, and the variable, you can see that here is x to the 4 and x to the 4. So instead of making cross this time, I just look at these numbers. 4 times 1 is 4 and 4 plus 1 is 5. So I just pick those numbers and add it here. And now I figure out that x to the 4 goes here and this x to the 4 goes here. So this is going to be your complete factorization. For next question, letter A and question number 9, they are also challenge problems. And for that, I'm going to change this expression as 25x to the power 4 times to the power 2. So x to the power 4 times 2 would be x to the power 8, and 25 square would be 625. So we can write this expression as 25x 4 to the power 2, and 256 is a 16 square. Here I'm going to apply the a square minus b square, where a is 25x square and b is 16. So that's going to be a minus b and a plus b. This expression will be same as it is. We cannot make any changes on here. But for this expression, I can break this further down, because 25x to the power 4 can be written as 5x squared to the power 2. So 5x squared to the power 2 and -4 squared. We can further break it down as 5x squared minus 4 times 5x squared plus 4. And that's going to be your complete factorization. Next is number 9, where you find out the common monomial if there is any. In this case, we can see that the w squared is a part of every term, as well as 5 is a factor of every term. So 5w squared is a common monomial. Factor it out. 5 cancel. W6 divided by w2 would be w to the power 4 minus 5w squared plus 6. Here we are going to apply the cross method, but I did not write the cross. I actually was using logical thinking rather than writing it. What we need actually is two numbers that multiply to get 6. So that's -3 and -2. When we multiply -3 times -2, we get 6. And add to get -5. So when we add -3 and -2, we get -5. So that's how I got these factors. And it's going to be w squared minus 3, w squared minus 2. If you want to make a cross, you can do that. So here is 6 on the top, -5 on the bottom. And the two numbers you're looking for was -3 and -2. The next thing we are going to discuss is the factor theorem. A polynomial fx has factor of x minus k if and only if f of k equals 0. In the previous lesson, we found f of k using synthetic division and using substitution. Means you use x equals k and divide the polynomial with that using synthetic division, and you find the remainder as f of k. The other method we use is that we use x equals k and we substitute for the k value or x value and found the f of k that way. Now, we were finding the f of k as a remainder, but if the remainder becomes 0, then we say that x minus k is a factor. If the remainder is not 0, then x minus k is not a factor. For example number 5, we are going to determine whether x minus 2 is a factor of this polynomial, which is x squared plus 2x minus 4. You're going to see if x minus 2 is a factor. To find f of 2, if f of 2 becomes 0, then it's going to be a factor. If f of 2 is not 0, then x minus 2 is not a factor. You're going to use this time direct substitution. So as I explained already that there are two methods to find f of k or f of 2, either by using substitution or synthetic division. Remember, you're going to use 2 if x minus 2 is given because you actually found its value. So x equals 2. If it is written in this form, you just use 2 automatically. But if it's written in the form of x minus 2, which is a factor form, then you choose the opposite sign. Now we are going to plug in x value, that is 2, into this x places. So f of 2 is 2 squared plus 2 times 2 minus 4. 4 plus 4 minus 4. 4 and 4 cancel and we got f of 2 equals 4. So which means that f of 2 is equal to 4, which is not equal to 0. So it means, therefore, x minus 2 is not a factor. Is not a factor. Remember, to make x minus 2, or to have x minus 2 is a factor, we need to have the value of 2 when you plug it in. It should be equal to 0. It should be equal to 0. Now you're going to check if x plus 5 is a factor of this polynomial or not. Now we're going to use the opposite of x plus 5. So x value is actually going to be -5. So we're going to find f of -5 using synthetic division. Make a L, and here goes is the number -5, and these places will be coefficient of the polynomial. So we're going to have to complete the polynomial first by inserting 0 for the missing term. So we're going to have to add 0x because x term is missing. And now the coefficients are 3, 15, -1, 0, and 25. Now we are going to do the synthetic division and see if we get remainder 0. If we get remainder 0, it means x plus 5 is a factor. And if we don't get remainder 0, then x plus 5 is not a factor. So bring down the 3 as it is. -5 times 3 is -15. And that's 0 when we add them. 0 times -5 is 0. -1 plus 0 is -1. -1 we are going to multiply with -5, so that's going to be 5. 0 plus 5 is 5. And now we're going to multiply this 5 with -5, and that gives us -25. And you can see that when we add the two numbers 25 and -25, that gives us 0. So it means that x plus 5 is a factor. We are going to discuss U-try problems A, B, and number 10. For this problem, letter A, I'm going to use a synthetic division. So remember, if it is written in right next to x or in a factor form, then you have to find the x value using its opposite sign. So you're going to use +3 if it's written in x minus 3 form. If it's already written in x equals 3, then you use 3 anyway. If this is the one that is written in, use opposite. If it is written in x equals, then you use the same. So I'm going to use 3. You bring down the 1 as it is. 3 times 1 is 3. 6 plus 3 is 9. 9 times 3 is 27. 27 minus 12 will give you 15, which is not 0. And if f of 3 is not 0, then x minus 3 is not a factor. In this case, the coefficient is 2, 10, 11, -1, and 6. Again, it is written in factor form, so I'm going to use -3. Bring down the 2. 2 times -3, -6. 10 plus -6 is 4. 4 times -3 is 12. 11 minus 12 is -1. -1 times -3 is +3. -1 plus 3 is 2. 2 times -3 is -6. You got the remainder 0. It means x plus 3 is a factor. Now for number 10, I'm going to use the substitution to determine if this is a factor or not. Again, this is given in x minus 4 form. So I'm going to use the x value that is equal 4. So if it is written in a factor form, use the opposite sign. Plug it in 4 for the x value. So f of 4 is 2, 4 squared plus 5 times 4 minus 12. And that's going to give you 40. That's not 0, so it means x minus 4 is not a factor. Example number 6, we are going to find and see if the given number or given factor. In this one, it's given as a number. So it tells you exactly that you're going to use -3 to determine if x plus 3 is a factor or not. Or you can take the number from here. You're going to choose -3 and use synthetic division to bring it down this fourth degree equation to 3 degree or third degree equation. So I'm going to use -3 and then here is the L. I have to complete this equation, so 3x cubed plus 0x squared minus x minus 3. I'm going to use the coefficient, and that's 1, 3, 0, -1 and -3. Bring down the 1 as it is. -3 times 1 is -3. 3 minus 3 is 0. -3 times 0 is 0. So add 0 plus 0 is 0. 0 times -3 is 0. -1 plus 0 is -1. And -1 times -3. So the last one is -1 times -3 is going to give us a positive 3. And then the remainder is 0. If the remainder is 0, then we can easily say that x plus 3, or this factor, is a factor. So x plus 3 is a factor. Now we are not just stopping here. Now we have to factor it completely. We have to factor this polynomial completely. So the formula is, when the remainder is 0, the formula is dividend equals divisor times quotient, because remainder is 0. Now the divisor is the one we divide with, that is x plus 3. And the quotient, we get it from these numbers right here. So starting from, so this is the highest degree 4. We are going to start this one with the degree 3. So x to the third plus 0x squared plus 0x minus 1. Ignore these two. So the answer is x cubed minus 1, and that's your quotient. Now we are going to apply the cube formula here. So we use the cube formula. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. Now x cubed minus 1 cubed. I'm applying the formula onto this polynomial right here, and I'm writing it as x cubed minus 1 cubed, where a is x and b is 1. And then the complete factor are a minus b, which is x minus 1, x squared minus x times 1 plus 1 square. So the factors are x minus 1, x squared plus x plus 1. So these are the complete factors of the polynomial given x to the 4 plus 3x cubed minus x minus 3. Now we are going to show if x minus 2 is a factor for the polynomial x to the 4 minus 2x cubed plus x minus 2, and then factor this function completely. First we are going to complete this equation by plugging in 0x squared, because 0x squared is missing, so x squared term is missing. To write down 0x squared for a missing term, I'm going to use x equals 2. So remember, this is in a factor form, so we're going to use a opposite sign. So we're going to use 2 for synthetic division, so 2. And right here you're going to write down the coefficient, that is 1, -2, 0, 1 and -2. Bring down the 1 as it is, so 2 times 1 is 2. Negative 2 plus 2 is 0. So 0 times 2 is 0. 0 plus 0 is 0. 0 times 2 is 0. 1 plus 0 is 1. So 1 times 2 is 2. You're going to add negative 2 plus 2 as 0. So the remainder is 0, means that x minus 2 is a factor. Now you're going to turn these numbers into a quotient form. So start always 1 degree less than 4. So you're going to start here 1x cubed plus 0x squared plus 0x plus 1. Since zeros doesn't mean anything, we just use to complete the equation. We can rewrite this equation as x cubed plus 1. Now we're going to use the formula that is dividend equals divisor time quotient. So divisor is x minus 2, quotient is x cubed plus 1. And here I am going to apply the formula a cubed plus b cubed. So that's formula we just did in the previous example. So this is going to be x minus 2 x plus 1 times x squared minus x plus 1. And this is going to be your complete factorization of this polynomial. Now we are going to use question number 11, and we are going to show x minus 6 is a factor of this polynomial. Then we are going to factor it completely. To show that x minus 6 is a factor, we are going to use synthetic division. So write down the coefficient 1, negative 5 and negative 6. Bring down the 1. 6 times 1 is 6. 6 minus 1, 5 is 1. 1 times 6 is 6. The remainder is 0. It means that x minus 6 is a factor. So x minus 6 is a factor. And now we're going to turn this into a quotient form. So now we're going to start from 1 and start from 1 degree less than whatever we have here is x to the third. So we're going to start it here x to the second plus x, and then take out the x from this to have into a factor form. So this is the standard form for quotient, and this is a factor form for quotient. So take out the x from here, take it out here, and it is going to be x plus 1. Now the formula is to find the complete factor is dividend equals divisor times quotient. Divisor is x minus 6. Quotient is x squared plus x, or x times x plus 1. So divisor is x minus 6. Quotient is x times x plus 1. So the complete factors are x times x plus 1, x minus 6 for this polynomial.